Limiting reactant. Before we get on to the limiting reactant part, you have to know the stoichiometric calculation. This is a chemical equation. From this chemical equation, we know that 1 mole of C3H8 produces 3 mole of carbon dioxide, 5 mole of oxygen produces 4 mole of water. 3 mole of carbon dioxide is formed from 5 mole of oxygen. 4 mole of water is formed from 1 mole of C3H8. This symbol represents to replace the terms produce or form from. So you can just write this symbol to replace these terms. Note that the coefficient shown in the balanced chemical equation is not always the actual number of mole of the substances. It means if it's 1 mole, 5 mole, 3 mole, 4 mole, these are not the actual number of the substances. It just represents the relative amounts of each substance. Example, how many grams of phosphorus react with 35.5 liter of oxygen at standard temperature and pressure to form tetraphosphorus dioxide? First, you have to write down the chemical equation of the reaction. So 1 mole of phosphorus reacts with 5 mole of oxygen to produce 1 mole of tetraphosphorus dioxide. Make sure the chemical equation is balanced before you start calculating. From this question, we need to identify the mass of phosphorus that can react with 35.5 liter of oxygen. We have the volume of oxygen. The question asks for the mass of the phosphorus. So you have to relate these two information. Now, in order to get the mass of the phosphorus, we need to know the number of mole of the phosphorus. We have the volume of the oxygen. We can convert the volume to the number of mole, so we can compare this information with the number of mole of phosphorus. We know that 1 mole of oxygen occupies 22.4 liter. It's at standard temperature and pressure, so 22.4 liter. And then, if you want to identify the number of mole of oxygen for 35.5 liter, do the cross multiplication, and then you get the value of X, 1.5848 mole of oxygen. This is the number of mole of oxygen. So you can compare a 5 mole oxygen equivalent to 1 mole phosphorus. But we don't have 5 mole of oxygen. We only have 1.5848 mole of oxygen. So, if this amount of oxygen equivalent to 0.3169 mole of phosphorus, just do the cross multiply. Now we have the number of mole of phosphorus. We can get the mass of phosphorus by multiplying the number of mole of phosphorus with the molar mass. You get 39.3 grams of phosphorus. Limiting reactant. Reactant that is completely consumed in a reaction and limit the amount of products formed. So limiting reactant used up first in a reaction. We use this to determine the amount of products formed. If you are comparing the amount of products formed, you have to compare with the limiting reactant, the reactant that is used up first in a reaction. I can give an example of limiting reactant. So, in order to produce 1 car, we need 4 wheels, 1 engine, 1 body, 2 bumpers. So given 20 wheels, 2 bodies, 4 engines, and 11 bumpers, how many cars can be produced? Only 2 cars can be produced because the limiting reactant is the body. So we only have 2 bodies. Even though we have more wheels, more engines, more bumpers, but we only have 2 bodies to produce a car. So the body is limiting reactant, the reactant that is used up first. Excess reactant are wheels, engines, and bumpers. In one process, 1 to 4 gram of aluminium are reacted with 601 gram of Fe2O3. Calculate the mass of Al2O3 form. First, you have to write down the chemical equation. 2Al reacts with Fe2O3 to produce Al2O3 plus 2Fe. Make sure you have to balance the chemical equation before you start solving the problem. Given the molar mass of Al, Fe2O3, Al2O3. Now, we want to know the mass of Al2O3. We have the mass of Fe2O3 and the mass of Al. We have the mass of both reactants. We want to know the mass of one product only. But now, which one are we comparing with, Al or Fe2O3? Because we have both information. We only need to compare with one reactant. The reactant that we need to compare is the limiting reactant, the reactant that will be used up first. We are going to use that information to compare with and to get the mass of the product of Al2O3. Now, find the number of mole of both reactants. Mole of Al, 4.593 mole, and then the number of mole of Fe2O3 is 3.761 mole. By dividing their masses with their molar masses, we have the number of mole of both reactants. From the equation, we know that 2 mole of Al produces 1 mole of Al2O3. 1 mole of Fe2O3 produces 1 mole of Al2O3. But that is just a stoichiometric, just a coefficient of the chemical equation. The actual number of mole of Al is not 2. This is the actual number of Al, 4.593 mole. And the actual number of Fe2O3 is 3.761 mole. Now, we want to find the limiting reactant because we need one of these. We need to know which reactant is used up first. Use that information to compare with the product. 2 mole of Al produces 1 mole of Al3. The actual number of mole of Al produces 2.297 mole. Just do the cross multiplication. Same goes for Fe2O3. Compare and do cross multiplication. If you compare the number of mole of the product, because we both comparing, Al compare with the product, Fe2O3 compare with the product. Then this one compare the coefficient, and for next one compare the actual number. Notice that the product mole is fewer when you compare with Al. 2.297 is less than 3.756. The number of mole when you compare with Al is less than when you compare with Fe2O3. So the one that has less number of mole of the product is the limiting reactant. Means Al is the limiting reactant. That's how you identify the limiting reactant. The one that produces fewer number of moles of product. When we know that Al is the limiting reactant, use that number of mole to find the mass. If you use this number of mole, this is not the limiting reactant, so you're gonna get the answer wrong because this is not the actual number of mole of Al2O3. You don't have this much, you only have this much of Al2O3. So you can find the mass by multiplying the number of mole with the molar mass. The mass of Al2O3 is 234 gram of Al2O3. Next example. How many grams of solid aluminium sulfide can be prepared by the reaction of 10 gram of aluminium and 15 gram of sulfur? The equation is given. We have the information for the mass of aluminium. We have the mass of sulfur. We need to know the mass of the product. How much of reactant is in excess? Now we need to know the reactant in excess. The question previously asked for the mass of the product only. Now the question asks for the reactant is in excess, which means the mass of the reactant is in excess after the reaction completed. Number of mole of Al. We have to find the number of mole of both reactant first because we need to compare all this with the product number of mole. So find the number of mole of both reactant first by dividing their masses with the molar masses. You get 0.3703 mole Al, 0.4673 mole sulfur. Now we have the actual number of mole of Al and S. 2 mole Al, 3 mole S is just a coefficient, so you can compare. 2 mole Al produces 1 mole Al2S3. This is from the equation 2 mole, 1 mole. We don't have the actual number of mole of Al is not 2 mole. The actual number is just 0.3703. Do cross multiplication, you get the number of mole of Al2S3. You have to find the limiting reactant first because we have both information. We don't know to compare with which reactant because we don't know the limiting reactant, so we have to find the limiting reactant first. 3 mole of S produces 1 mole of Al2S3. So the actual number of mole of S producing 0.1558 mole of Al2S3. Do the cross multiplication to get this number of mole. So now we can compare which one has the fewer number of mole. When you compare with S, the number of mole of the product Al2 is fewer, so the limiting reactant is sulfur. So now we want to know how much of reactant is in excess. Now we have the number of mole of Al2S3. First, compare the excess reactant with the limiting reactant to identify how many mole of excess reactant was used up. We have excess reactant with limiting reactant. Our excess reactant now is Al because S is the limiting, Al is excess. We want to know how many is excess, so compare both reactant together, and then the initial excess reactant means before the reaction minus the excess reactant that was used up. Then we get the reactant in excess that is left. 3 mole of S equivalent to 2 mole of Al. Compare the excess and the limiting reactant. Compare the excess with the limiting reactant. We get from the previous one, the S is the limiting reactant, so Al is the excess reactant. Okay. Then when we compare, you put the actual number of mole of S, 0.4673. 0.4673 mole. This is the actual number of mole of S. Then you do cross multiplication, x mole of Al. This is the number of mole of excess reactant when you compare with limiting reactant, don't put the number of mole of Al, which is the actual number of mole. We're not taking directly from this number of mole. It's not 0.3703 because this is the excess number of mole. We want to know if this is the limiting number of mole. We need to know how many number of mole of Al when this is the limit. So that's why you do the cross multiplication. So you get 0.3115 mole of Al. It's not even 0.3703. It's less than that because we are comparing with the limiting reactant. So this is a number of mole of Al. This number of mole is used up. When you use up this number of mole of S, this number of mole of Al is also used up. For them to react together, both number of mole used up. And then step number 2, the initial excess reactant number of mole. This is the initial number of mole of Al. Before the reaction start, you have this number of mole of Al. But during the reaction, 0.3115 mole of Al is used up. So minus 0.3115 mole. After the reaction, only 0.0588 mole of Al left. So we have the number of mole that is left after the reaction. We want to know how much the reactant in excess, convert it to mass. Mole times molar mass, you get the mass of Al. So this is how you get the reactant in excess after the reaction completed. You have to minus with the number of mole that is being used up.